Okay, so here's the last review video, and so this one's on perimeter and area. So perimeter is just the distance around. So if a guard says, I'm going to walk the perimeter of the premises or the building, they mean they're just going to walk the outside. They're not going to walk in the middle. They're walking the perimeter, which is just the outside. So if this is, say, 3 centimeters, then you're just counting distance, 1, 2, 3, and then maybe this is 1, 2, 3, 4 centimeters. And then someone's going to have to tell you the slant right now. So right now this is 5. They're telling you that the slant length is 5. So you're just going to add up 3, 4, and 5 to get the distance around the shape. It's kind of like you're putting string around it. So that would be what, 9, what is that, 12 centimeters would be the perimeter. And you're not counting squares, so there is no square centimeters here. You're just counting perimeter. Now area is when you count the squares. Now right now I can see that there's 1, 2, 3 full rectangles, but like these partial or squares, I mean, but I can't cut and paste these because they're not nice. If you look at them, they're not ending like halfway through, like it's not quite even how it cuts. So I can't like cut and paste and guess. So what I'm going to do instead is I'm going to make a rectangle. And if I make the rectangle, I get perfect squares. So you can kind of see if I go down this way, I have 4 by 3, and 4 times 3 is 12. But the thing is I only have half of those squares because I only have the triangle. I don't have the whole rectangle. So length times width, 4 times 3 is 12. But to get the area, I only have half that. So I'm going to take half of the 4 times 3. So half of 12 is 6, and these would be square centimeters because literally I'm counting the squares, right? And I would have just counted the squares, except I didn't quite know how to glue them to make them make full amount. So I made a rectangle where I had full squares, got the answer of 12 squares, and you can count them if you want, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but I only had half of them. Okay, for this trapezoid, I'm going to do the same thing here. This, if I count this distance, 1, 2, 3, and this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, someone's going to tell you the slant, which in this case is 9.2 over here. So I'm just going to add up all these sides to figure out the perimeter. And so the perimeter is 3 plus 6 plus 10 plus 9.2. And so if I add those together, let's see, what is this? It looks like this is what, 19 and 9.2. So is that 28.2, I think, if I can add. So I think that's 19, yeah, 19, so 18.2 and 10, yeah. And so that would be whatever unit. So pretend we're in inches this time, then that would be inches. Again, not squares. I'm not counting any squares. I'm just counting these flat distances like toothpicks laying around the outside. Now area would be the squares inside. Now again, notice these don't quite cut perfectly. So it's like, how do I glue this little tiny piece and that little tiny piece, and how do I make full squares out of that? That's a problem. I can't really, I could guess and maybe get close, but I just can't do it perfectly. So what I'm going to do is I'm going to cut this into that rectangle because I can see the length and width of that is 18. 6 times 3 is 18. And again, you can count the squares here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But length times width is faster. So that's 18. So for the area, I'm going to take that 18 from there. But then this triangle is not a rectangle, but it's half of a rectangle. So I'm going to draw in so I get perfect squares and I can count. Now this guy's not 10. 10 was all of that distance. This guy is not 10. So what is it? It's 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6. Okay, so 6 times 7 would be 42. And again, you can count these if you want, but 6 times 7 is 42. So there's 42 squares in here. But I only have half of 42 because I only have this triangle. I don't have all of it. So half of 42 is 21. So if I add those, what do I get? 39. Now, these would be square inches because they're square shapes. They're not, they're not just like you're counting inches. Inches would be just like the toothpicks laying around the outside. I'm literally counting squares. So that's where that unit of square inches come in. All right, this last one, perimeter, would be, again, that's like toothpicks or string going around the outside. So this is 3, 3, and then they tell you the slant is 4.2. So if you add up all the sides, and maybe this is miles, so maybe someone's walking around a triangular perimeter of a building, and so there's 3 miles, or a compound, maybe 3 miles, 3 miles, and 4.2. So if I add that up, I get 10.2, and maybe it's miles. Okay, so huge area. Now, to get the area, I could do the half of the rectangle trick, but look at this time they actually cut the triangles exactly in half, if you can see that. These are cut perfectly in half. So it's not like I'm trying to guess. I can predict that a half and a half would make a whole. So here I know I have 1, 2, 3 full triangle or full squares. These two together, a half and a half would make another one. So that's 4, and then I have half a one. So I actually know that the area is going to be 4.5 square miles. And again, I'm counting literally squares, so I know it's squares. But could I do that triangle thing I did up here? I could. So let's just make a big square. Actually, it's not even a rectangle, it's a square. And you can see it's 3 by 3, and you can count there's 9 squares in there. But again, I only have half of the 9 because I only have the triangle that's down here. I don't have the whole square, I only have half of it. So half of 9 is 4.5. So I still get the same answer even if I make it into a rectangle and cut it in half as what I would on the other. One thing I forgot to talk about in one of the other review videos is degree. So if you have a polynomial, remember polynomials have nice exponents on them. The degree is the highest exponent. So like this would have a degree of 3. If I give you x to the 8th minus 3x squared plus 10, this has a degree of 8. So when you have polynomials, like this is a trinomial degree 3, polynomial, that's a trinomial degree 8, and you can have maybe a binomial with degree 4. So the word degree, I forgot to highlight that vocab word, but make sure you remember to study that as well. All right, that's all I have on that unit. And oh, there was one question. Yeah, let me finish this quick. So some people asked about, so say the original rectangle was 8 by 6. And so again, if you have 6 this way and 8 this way, the area would be length times width, or 48 square whatever feet. The perimeter is just the distance around, but again, there's 4 sides. So 8 and 8 is what, 16. 6 and 6 is 12. So what is that? 28, say, feet, not squares. You're just doing around the outside. And it talked about how, like, if you double both, okay, so if I double both, I get 16 and 12. Okay, so again, what happens to my perimeter? Well, 16 and 16 is what, 32. 12 and 12 is 24. So that's what, 56 feet. Okay, now my area is 12 going this way, right? And 16 going this way. So I need to take 12 times 16 to figure out how many little squares would be in there. So 12 times 16 would be what, 192, and that would be squares, so square feet. And it talks about what happens to the perimeter, what happens to the area. So if you look at the perimeter, it went from being 28 to 56, so it doubled. So the perimeter actually doubled. So what happened here, and again, I'm not going to draw it to the same scale, but if I have 6 and I double it, I get 6, another 6. But if I had 8 and I double that, I have another 8. So if you look at the perimeter, you have 12 and 16, but then you'd have, 12 over here and 16 down here too. So it makes sense that the perimeter got doubled. But notice what happened to the area. This is the area. This was your 48 square feet. But notice if you make it twice as long, you get another 48 square feet over here. But then you make it twice as wide, you get another 48, oopsie, can't write, another 48 square feet here and here. So you can kind of see how, like, when you do the perimeter, it just doubles it, but when the area, it gets 4 times bigger. Okay. Another tricky one that you might see on that, let me just find some scratch paper here, is that it might say maybe your original shape is 4 by 3, and maybe these are feet and feet. And so again, perimeter, you would add up all of the sides, and then to get the area, 3 by 4, you'd multiply and get 12 square feet. But then maybe it says that it's like 20% larger. So remember, that would be 120%. So your multiplier would be 1.2. So what you're going to do is you're going to take the 4 times 1.2 to make it 20% bigger, and the 3 times 1.0, or not, sorry, 20%, 1.20 here. And so your new shape is going to be 20% larger. So you're going to take 4 times 1.20, and that's going to give you what, like 4.8, say, feet. And then take 3 times 120%, so 3 times 1.20, and you get 36 feet, or 3.6 feet, sorry. And so again, if I'm going to do the perimeter, I'm going to add all 4 numbers up, and my unit would just be feet, because again, I'm just kind of walking along the outside here. All right. And so my feet, and then area would be length times width, because I have a full rectangle here. So I take this times this to get how many kind of squares are in here. And again, it would be in square feet, because you're literally counting squares. So I know there's a couple kind of tricky ones a little bit on homework. I would not probably put those on the test. Okay. All right. So I'm going to end it here. Keep studying hard, and I will see you in class.